Much, everybody, for joining in the GIST Council today. I'm wanting to discuss issue 424, which is a proposal for a class within GIST for a complex relationship, or potentially complex relation. That's something that we perhaps need to discuss. And the other thing is that given that I'm surrounded by a bevy of total experts, I feel myself more like, coming out with the midwife of ideas, the sort of Socrates of the bunch. So, feel free to join in with your best ideas, stick things into the chat so that we've got a record of them, and so on. So, to start off with a kind of motivating example, if we were to say that Sam has liked Tam for 3 years, when we begin to encode it in RDF, we're stuck with the problem that, generally speaking, RDF is a kind of point-to-point subject-predicate-object approach. So relationships are binary. But we know that over recent years, people have been looking at things like labeled property graph relations and feeling the richness that they offer with the inner structure of predicates so that they can be annotated, as you see in the second graphic down. And we've known for quite a time that RDF can address this in a potentially awkward way using what's called reification. And that's shown in this third graphic down here. Or the alternative might be for singleton properties, which is shown in this graphic here. But in recent years, months, we've been having the discussion that's led to the development of RDF star. And this is, of course, it's its latest representation without the asterisk, where we have the opportunity of having nested triples in order to make reference to them in this sort of double angle bracketed way with turtle. Now, already in GIST, there is a kind of reification of a temporal relation which connects one thing to another with a start time and an end time. And here's a kind of example of how that might be used, where we create a subclass of it and then use that to describe, in this case, the relationship between Michael Ushold and Boeing from 19th February 97 until 29th of March 2008 as a period of employment. And this is a very good practical example. It's the sort of thing that we get in business an awful lot. Because there are many, many use cases where we've got things like human life events or system component life events. Sometimes the events are of very long duration. Sometimes they just have a start date. But we get them in many areas. So the idea of just temporal relation is a really good one to have in the upper level ontology. It's going to be used quite a bit. But what about time independent relationships? Now, I guess you could sort of say that these have a start date, but in practice, things like composition and dimensions and display or placement of things don't in practice actually use a start date. So in the main, we don't want to kind of confuse them with the idea of something that has got a temporal relationship. And so we come to the proposal in that issue, which is that we have a reification between two or more individuals where we can represent these any relationships and attach additional information about the link between the two in as a complex relationship, meant to be used in exactly the same sort of way that temporal relation is, so subclassed and worked out for the particular case in hand. And in pictures, it's something a bit like this, that we have a complex relationship, which is a subclass of something on property connected to with a minimum cardinality of 2. And there are, in the proposal, a few kind of helpful predicates that are optional. So there's the potential to have a pointer to an object, or pointer to a subject, and a pointer to the property that that is reified here. And in the same way that I demonstrated the temporal relationship, here's an illustration of a complex relationship, which is looking at the placement of a cog on a spindle, the cog having 10 teeth, it being spindle number 2. Something very similar to what we saw in the picture earlier. Now, there are many other ways of doing this with blank nodes, where people create predicates and they create classes for the specific use case. And if you take a look at, for example, the prov standard, there are many qualified forms in there where there are these predicates where the expectation is that you'll make a blank node of a particular type and put the information in there. So the question really arises, why the heck don't we do that? Why don't we just kind of leave it and deal with it in a blank node way? But then we'd be herding sheep, and herding sheep really takes a lot of skill, particularly if you want to do it as well as in this picture here. And we don't really want to be putting in that amount of effort, because the reason is that we use an upper level ontology, and an upper level ontology is there to act as a hanger for various things so that we can bring them together across multiple sets of information. And so there is benefit in not using the blank node approach, but actually thinking about something more specific within our toolkit of the upper level ontology. And so the proposal is that we look towards adding a new class to GIST of complex relationship, or complex relation if we wanted to even it up with the existing temporal relation. And that we would then make GIST temporal relation a subclass of it. But also, as I'd shown with the illustrations of both temporal relation and the complex relationship, we wouldn't expect people to use them raw. We would really want them to be subclassed for real world use. But the other thing that we have to also think about at this point, given that much technology that we're currently using is moving to be capable of working with RDF star and Sparkle star and so on, is that we also have to consider at what point we embrace that in our work. That doesn't mean to say that the two things are mutually exclusive, but what it does is that it gives us additional ways of thinking about reification. And we need to be thinking about what the consequences of this are and what the appropriate design patterns are for when we want to use it, recognizing that what we deal with is the benefits through GIST of an upper level ontology and having these hangers that enable us to kind of come into complex data sets from a high level, knowing that we'll be able to pick everything up that's mapped to it at a lower level in the knowledge graph. And so in the discussion that I would like us to engage in now are really kind of three questions. One of them is, do we need this new class? And that can be balanced by, the question, is using blank nodes adequate, And then the other thing is where we see RDF star coming in, since we are talking about reification, and RDF star kind of hits it square on. So I'd like to finish my presentation now and pass it over to you, but not without having a little chuckle about this reification cartoon on the right.
Nice. Nice.
Okay.
Peter, I don't know how you want to handle it, maybe with raising hands.
Well, and I think I'm going to come out of the slideshow now and stop sharing. If I can get to that one. And yeah, let's go for hands and putting comments in the chat. How does that work?
Okay.
So let me see, because sometimes it's the people thing that tells me who's first, doesn't it?
I think so, though it could be backwards.
So I've got Phil, Mark, and Rebecca. So should we just start with Phil?
I was actually first, but
all right. Let's start with Rebecca.
I saw my hand before I saw any of their hands. I don't.
All right. Okay.
Yeah, maybe upside down that way, because I think I was second. So
this is really helpful. So can we make sure that somebody captures things in the notes as well, please? Rebecca, the floor is yours.
So Peter, can you tell us what having this class would buy us? So not having this class.
So the thing that I think, Rebecca, is that it would give us something from which to sort of gather all of these reified relations. I think that the blank node approach is fine, apart from if you're the type of person like me who doesn't particularly like blank nodes. And so I think there's a lot of benefit in actually having proper IRIs for things and not sort of system dependent ones. So that I can look at things across multiple.
But you can have an IRI without giving it a type complex relationship. I don't understand that.
Yes, you could do. No, you're absolutely right. And the thing about it is that it's just that. So you would say, okay, use temporal relationship, but without the temporal relations. Is that right?
It depends, but I haven't yet seen, you went through those examples pretty quickly. I have yet to see a convincing case of one of these complex relationships that's not temporal. Doesn't mean there aren't any, but I haven't heard of one. For example, your cog and, what was it? Cog and wheel. I mean, there is a temporal relationship there, even if we don't care to state it. I mean, who cares at what point somebody stuck the cog onto the wheel? We don't care, but in fact, we know that it did happen at some time. It hasn't just been like that forever and will be like that for all eternity. So that's a temporal relationship, in my opinion.
So I understand that, but when we begin to start looking at things like tables of elements or something like that,
yeah,
I mean,
right. Okay, I admit that's different.
I mean, and the composition of granite. I mean, to all intents and purposes, these sort of things have been since the start of time, right, and will go to the end of time.
But then if that's the only domain that we find these things in, do we need to go up to the complete level of abstraction of complex relationship, or is there some other thing,
Rebecca, right at the beginning, I said, look, I'm surrounded by a bevy of experts.
No, I'm
Okay.
these are my
And I want to use this to be the midwife of ideas. And so
Well,
this
I'm
is
giving
really,
you
really
one.
helpful.
You've given
What
birth to
your idea is that in practicalities, everything has got time somewhere in it, even if you don't want to state it. And so the question then really is, why do we not just get rid of the notion of temporal relation and make that just one of the ways in which we deal with complex relationship?
Right. If you're extracting sentiment from text, you want to be able to attach the adverbs to something. So I think that's a use case.
Say
I
that
mean,
again.
adverbs are very fuzzy, and you probably don't want to put a lot of adverbs in your model for running a business. But but I think sentiment analysis is one place where they do show up, where you want to be able to capture them.
I'm not questioning the idea of this relationship object, a reified relationship. I'm asking the question whether we need something in addition to temporal relation, which we already have, or not. That's my question. In addition, the value of these other these associated predicates, which, as you know, I've taken issue with in multiple contexts.
So I think that this is a really valid question, and the thing about it is that if we take it that we will use this as a general class for reification, then we may want to just strip out the word temporal in it and have it as this sort of complex relationship class, which you then may want to add.
What does it give you, though? I'm sorry, I'm taking too much time, but I did have this email exchange with Ted in which he said this looks more like a design pattern than a class, and I think he hit that exactly right. What does having this overarching class give you? The temporal relation is, if you have a temporal relation, you can hang the temporal properties on that. I mean, the subclasses inherit those properties from it, but the complex relationship is so abstract that it doesn't seem to do anything for you. I don't understand the utility.
Right. So you've made a very good point.
Okay.
So
I'll put my hand down and shut up.
Let's put your That's no, not shut up, but let's go into listening mode and let's see what other arguments we get, because you've got a very powerful parsimony argument here. All right, Mark.
Okay. Few things. What does it give us? I believe it gives us a common, consistent pattern, a way of doing this. So to me, it sets a template, if you will. I will say two things. When I've done this with clients, it's the super class of temporal relation. So we would say there's a complex relation that has rel subject, has rel object. And then we would say, and reifies some property, and then we would say temporal is a complex relationship that has a start time and optionally an end time. So we actually turn it on its head, because we're saying
that was the proposal, Mark.
That is the proposal. Okay, great. So the next thing I guess I would say is why not use temporal? The current temporal, at least the current temporal definition, gives no directionality. In fact, it only has connected to. It does not have has rel subject, has rel object. So I think what this gives us, I think that pattern of has rel subject, has rel object is important, because I think properties that we're reifying are generally directional, and I think we need the directionality in the reified class, and I don't think temporal right now gives that, because it's just using connected to. So hopefully the proposal has the has rel subject, has rel object. And the last comment is you asked Peter about RDF star, and my biggest issue with this, and I've spent a lot of time with it, including going over to the Berlin workshop, and my issue with RDF star right now is simply that for our practice, not in the world in general for RDF graphs, but for our practice, we cannot tie RDF star constructs into our OWL really in any way. OWL has no understanding of these, angle bracket triples and things, and nor even with like RDF statements. Some of the traditional RDF reification, we can't use OWL axioms on those, I don't believe. But the point is, by making it a consistent pattern that we use, we do have the ability to say other things about it in OWL, and unfortunately we lose that with RDF star. I think you can translate from one to the other, but I don't think you can make OWL statements about the same construct if we decided to model it in RDF star. So I'll stop there.
Right now, my main computer shut down just then, and I'm on my phone. Okay, so wasn't that good that it all happened after I'd done my presentation?
Yes, that's right.
Yeah. So the question that I would think from that, Mark, is do you think that we need temporal relation if what we have is something in there that's a tad more abstract?
Yes, I do like temporal relation. And again, it gets to the idea of, just like I believe it's a bit artificial. I've heard all the arguments, but it still just feels kind of artificial to have to use temporal for everything and just use the open world as a way out of saying. So to me, to say there's a complex relation, and all we say in that one is there's things that have a rel subject and have a rel object. Interestingly, I would say it's usually some values from, so you could have multiple subject and multiple objects if you want. Some interesting relationships may be like that, like joint ownership of a house or something. But also, then I do think temporal is valuable in my mind to put as a subclass, because there again, a consistent pattern and way to do temporality, which is something we bump up against all the time. So to me, having that one under the other, having temporal as a sub of complex makes sense to me. And it's not just, theoretical. I've used this in practice with one of our clients for probably a year or two now. So, it hasn't, sometimes you actually start using something, you're like, oh, I really don't like how this plays out. But I have liked how it's played out at that client so far. It feels pretty good.
I mean, I personally feel that it's helpful to have these within the upper level ontology because it helps you sort of keep things tidy.
Exactly.
And gives you something to build out from.
Yeah, it gives you that top level pattern to slot things under.
I'm really a big fan of clothes hangers, but I think that you do need to have guidance on how to use them properly. Otherwise, people get a bit, can get a bit confused as to whether or not they would use a temporal relation if they've only got one time, for example.
Yeah, and again, I believe that, nice thing about GIST is it has somewhat abstract that idea of start and end. If you go to the top of the thing, they don't have to be historical or planned, right? It's kind of a little bit more general than that. So I would think we do it that way. You'd say there's a relation that's just using GIST start, some start, and possibly, and I guess I would say some end, but there again, not being known yet, because the way GIST properties work, that end could be planned, could be historical, or could be neither, right? It's just that parent concept that there's some kind of an end there.
Phil, are you next?
Yeah, sure. Temporal may at some point, you may encounter cases where you want to go bitemporal, which it gets a little more complicated, which is just a kind of general comment. But I think more to the point, reification really is not a very natural concept to people, I guess. But I think triple is. And to me, what you showed with the double bracket notation could be an IRI, and you could say that triple as a concept becomes a class. And I think that's probably equivalent to your complex relationship class.
That's RDF reification that you're describing.
It could be. I haven't investigated RDF, but
That's what that is.
nested triples, actually, putting a
Having-
property, saying
that-
you have a triple as an instance, if you explain it that way instead of talking about reification.
But that
you'll
is,
be able to
that
relate
is
to it.
different. That's a different structure, though. That's having a subject, predicate, and then the object is a triple, an RDF statement. That's the structure you're talking about. Peter mentioned that it's RDF reification. It's not having this relationship class. It's a different concept. Anyway.
Maybe. But I think, everybody working with ontology should understand what a triple is. So I don't think it's a big leap to say, okay, triple now as a concept, it becomes a class. And the idea of a graph is also not too much of a stretch for people to understand. And I think putting properties on triples is equivalent to having properties on the edge of a graph. So there is a little bit of a leap there between the concept and the way it's expressed, but I don't think it's too big. So that's my input. And I've done a couple of write-ups on that. And Peter, I'll send you what I've done there. Thanks.
Peter, you're muted.
Ted?
Okay, I have a question. I might have missed something that you did go through the slides pretty quickly, and I haven't spent a lot of time with complex relationship. But one of my fundamental questions is, suppose you have a complex relationship that has a temporal aspect as well. Can I represent that in a single complex relationship individual? So am I going to have has-rel subject, has-rel object that compete with each other? How's that work?
So remember that the has-rel subject, has-rel object are kind of optional, and they're in there just to help people if they need to provide some sort of directionality from things. Okay. The other thing is
I'm sorry, I'm surprised that they'd be optional, because how do you know what the complex relationship is about?
Yeah, I didn't think they were optional. I'll have to look at the proposal. I thought we said that the parent of complex relation does need has-rel subject, has-rel object.
Mm-hmm. Michael's going to.
It's optional in the sense that you don't have to use those predicates. For example, employment. You can just decide to say employed by, employs person. You can create object if you want to, but you don't have to use them in your actual triple store. But
okay, so that makes sense to me. But then logically, I think, logically, not necessarily in your proposal, but logically, every property that is going to be part of a complex relationship object would logically be a subproperty of has-rel subject or has-rel.
No, just okay. The complex temporal relation is to say is something happening for a period of time. It's some relationship holding between two individuals for a period of time. Complex relation, the generic thing, is just a relationship between two individuals. Period.
Right.
You want to say something else about it. So if it's a relationship between two individuals, you have to specify the directionality.
Right.
If you don't want to, you can specify directionality by giving nice names to the relationships, pointing to the employer and pointing to the employee. Then you get your directionality that way. If you don't want to do that, because it's often difficult to think of good names, then you can choose to use has-rel subject and has-rel object.
Okay, so if I want to say there's an employer-employee relationship between two objects, and it existed for this period of time, and the relationship was supervisory, can I do all of that?
You could do all of that within temporal relation.
Right. Yes.
Right.
You would create a subclass. You would create a subclass of, in this case, a subclass of temporal relation, where if you wanted to require all that other stuff on there.
Okay. So what I'm really struggling with is then what has-rel. You're establishing a class which is stating that there's always a has-rel subject and a has-rel object, whether or not I state them. Open world, right?
In effect, yes.
Okay. But in fact, I may use other properties to give more specificity.
Right.
Yeah.
Okay.
Let me just comment here. I think it's the same client that Mark referred to, Mark Wallace, a few minutes ago. We had a long discussion about this. They're a little bit clunky, they're a little bit geeky, they're a little bit abstract. This has-rel subject and has-rel object. They're kind of ugly, frankly.
Yeah.
Right?
Mm-hmm.
So we had a conversation in a committee room where I was presented this, and he squawked and said, "What's that?" In a polite way. And we like this person a lot. He said, "What's this all about?" And I explained it, and I said, "It's a choice. You can use this and then not have to keep inventing more and more and more and more property names that are really hard to think of names for. And when you look at the name, you don't know what it means anyway. Or you can have one. Mark, you might have been in the room at that time. I don't remember. And eventually, the client said, "Well, okay, I can see that logic. Sure, let's go that way." So that's the actual experience with the real client.
So I think then that the coat hanger analogy is probably best. It seems to me that complex relationship as a class is not actually communicating a lot of semantic information other than to say, by the way, I'm following this pattern.
Yes,
yeah,
exactly.
Classes. Otherwise, you have this plethora of
Yeah.
classes hanging around. Mind you, never going to be dozens, but it's always nice to have a place to put something.
Let's get back to the hand raising. I think John's been waiting patiently.
Yeah, my problem is
I was just about to bust in. I think it's important when you introduce an abstract concept like this to have at least two examples, two subclasses of it. And the one I had in mind, and that I have had in mind ever since I heard of RDF, which was pretty early, is like provenance. Who claims this? And I think this would be the time to introduce a complex relationship class called provenance. And also to point out that these subclasses of complex relation are by no means mutually exclusive.
Yeah, and just to interject, for my NLP application at Morgan Stanley, I had to do exactly this. I had to introduce provenance, who said it and when did they say it, in addition to, and what time period was it about, or perhaps what time instant was it about. In the world of finance, some financial results apply to a period, a quarter or a year. Some financial results are as of, the end of that period.
By temporality, yeah.
Yeah. So, well, that's not really by temporality. That's really the temporality of the subject matter. Are you talking about the profits the company earned over the course of the year, or are you talking about their balance sheet at the end of the year? That's one aspect of temporality. Then the next aspect of temporality is who said it. Well, I'm sorry, that's not temporality, that's provenance. But part of that provenance is when did they say it? So you get this really interesting, try temporality. You get this really interesting situation. The company's quarter ended September 30th. They're going to announce the results on October 15th. And between September 30th and October 15th, all the well-paid people on Wall Street are going to make money by guessing what the company is going to say on October 15th. And that's what they get paid the big bucks for, is to guess. And so you've got the situation that on October 8th, an analyst said that the company will say on October 15th that their revenue for the quarter ending September 30th was this. So you've got times all over the place,
You do.
yeah.
And so
Polytemporality.
Yeah, polytemporality. There you go. That's the general case. So
Dave, are you sorry? Okay.
I was just going to say I did all of that without reference to temporal relation or complex relationship. And I'm just, wondering if, I have this solution, it's working. Can I hang it on complex relationship? And if I do, is that appropriate? Because
it sounds as though it might just be the right clothes hanger for it, Ted. Yeah.
I would ask this, Ted.
No. Can we stick? We got a whole bunch of people with their hands up.
Dave has waiting patiently.
You have, haven't you? And so has Boris.
Yep. 3
If
quick
you've spoken,
points.
put your hands down, unless it's a fresh one, please.
So 3 real quick points. One, we tend to rush to reification and claim that RDF star is reification, all that kind of stuff. I don't think that's a very good idea. I think reification is a horrible complication, and it's just a suggested a possible implementation, not the suggested. It's a terrible implementation of RDF star. And when we back away from that, we should look at RDF star as saying, we really just want to say something about the edge. We don't want to blow this thing out. Point number 1. Point number 2, I agree. I would like to avoid blank nodes. I think there's all kinds of problems with blank nodes. So your solution, setting aside blank nodes, good idea. Now, here's the real issue. I think we already have a bunch of complex relationships. I think time, the way we've got it in GIST, I think magnitude, I think we did characteristics and specification and stuff. Those are all complex relationships. But I don't think they're benefited much by saying they have a common ancestor. I don't get it. I think they're better in their specificity than they are in their generality.
Exactly what I've been saying.
Totally agree. Totally agree. That's why I'm wondering the value of these Hasrel subject, Hasrel object. Yeah.
Right.
These are all extremely useful comments, and I hope that we're gathering them all together. I know we're recording them, but just a couple of notes in the chat would make sure that we get them. Boris.
So a couple of things. First of all, and again, with you saying we don't necessarily need to have these things are better off in their specificity, and you do not need a kind of a general parent, class, and set of relationships. Sometimes when, and I'm kind of stepping back into a software designer role, you want to be able to query your data in a general way. If you have some general patterns for visualization purposes, for comprehension, for detection of connection, it is sometimes beneficial to be able to inquire about complex relationships in a generic manner. And in that, a class that does not necessarily have deep inherent meaning, but suggests a way of connecting entities has value. I'm not saying that it's the right answer, but this is one of the places where value is present. The other one is the proposal that Peter had did not mandate a subject and object. And I know the customer where we originally sort of came up with this did require a subject and object. But if you look at the definition that Peter had in his presentation, it requires a minimal number of 2 connected things that have some sort of roles in which they participate in a complex relationship. You know, the engine transmits power to the rear wheels through the drive shaft, right? Is an N-ary relationship. You can have N can be bigger than 2, and you can indicate it, and there's a different things in directionality. There is a different ways of participation that you want to be able, like you obviously have, you know, you can model things very specifically for a particular case, or you can do them as an extension of a pattern because it allows you to then visualize, let's say, how a car is put together by interrogating some of these more complex relationships. And as far as, you know, all of the other things that we're talking about, you know, provenance and et cetera, they can find a home in this, but the issue I think that we need to distinguish is, in cases like provenance, are we just providing metadata about a relationship? There is no association between the meanings, versus a complex relationship where all of the various pieces actually have a qualitative effect on the meaning of the relationship. Like, and I don't think of those necessarily just because they can use the same pattern doesn't mean that we necessarily should. That's all I had.
Okay. Now, although Rebecca, you're next, we've not heard from Dan, so I just wondered if I could swap you round.
No.
Ha!
Yes.
Dan.
Okay, just real quick. One of the key distinctions between complex relation as proposed and temporal relation as it exists in GIST is that temporal relation, the time component uses time instant,
Yes.
that class. If for some reason you or your client do not wish to use time as instance, as objects, and instead want to have a data property to capture your date time information or whatever, then you're out of luck. So this is, this is one distinction in this, proposed superclass over temporal relation.
That's really, really helpful. Okay, thank you very much for that. Rebecca?
Is there anyone else who hasn't spoken yet?
No, Michael has had a few bites of the cherry, so you just come back in and then I think we've got about, I don't know, how many minutes have we got? About 5? Or
it's only 11:45. We've got, don't we go till the hour?
We got about 14 minutes.
Yeah.
Okay, fine.
So
Good.
I've had this, well, first of all, I'll say this about the n- ary relationships. This model using has-rel subject and has-rel object only addresses binary relationships.
Otherwise, rel subject and rel object don't mean anything.
Yeah.
Only if you use has-rel subject, has-rel object.
I said has-rel subject, has-rel object. If you use them, then it's only a binary relationship. Otherwise, you're going to have a specific relationship, which is defeating the whole point. The whole point is to allow you this mechanism of connecting the instances in a relationship without specifying specific predicates, right? So this only handles 2. Now,
so hold on, just with that. So Mark is in the chat saying that he disagrees. Mark, meet Rebecca.
All I was saying, I will agree that it puts a directionality, but I would disagree that it has to be one subject, one object. My example is my wife and I both own my house.
Okay,
so
well,
I could have 2 rel subjects, 1 rel object, and I understand the directionality of owns relation.
Yeah, I would actually model ownership in a very different way, so I prefer not to use that example. But because I think ownership itself is an object, because you have to be able to specify percentage. And date times could differ for different members of a joint ownership.
Yes,
anyway,
absolutely.
That's a side topic, but I just reject or I don't think that's the best example. So given that we have only, let's say our purpose here, one of the purposes is to avoid minting a pair of properties per relationship. And just using these general ones. This only gives you 2. I suppose you could have has indirect object or has, other, you could add others, I suppose, but at that point it becomes unclear. No, you couldn't really, because then you can't point to what predicate you're reifying. So now here, you don't, so a second point, when you use has-rel subject, has-rel object, you still don't understand that unless you use reifies property, right? So in an employment relationship, if I say, it has rel subject, semantic arts has rel object, Peter, I only can interpret that if I have the predicate employs. Exactly. So now I have one of 2 predicates. So now you've only saved me 1 predicate.
Yeah.
And I have a conceptual difficulty with saying that an employment relationship has this kind of directionality. Okay, it's a relationship between 2 things. There's not really a subject and an object. I know you're saying there is, but there isn't in reality. In semantic terms, it's just a relationship between two things. I don't know
Well,
how.
but hold on, Rebecca. Whenever we define anything in normal OWL, we agree that it has directionality. Every predicate is directional. So to say that we can't make relationships unless they're non-directional doesn't make sense to me. Whenever we define anything in OWL, it's directional unless we make it symmetric.
I think you're using the word directional in two different senses.
I guess what I'm saying is we've spent, 2 decades now modeling things in OWL with a very clear directionality on the predicates. And I'm just suggesting that when you make a complex relation to reify that predicate, it's just as clear as it would be in the relationship definition itself.
Okay, so we've gone through this before. Employment also reifies the inverse. It reifies both employs and is employed by.
Which is why I don't like employment as a class definition. In other words, I'm suggesting the complex relationship, and again, maybe we need a subclass of it, I guess. I mean, the idea that there are, it may not cover all cases, right? So maybe we need to think about that, but there is an extremely common case of directional relationships between two objects that need more said about them. And I'm just saying, I see a pattern here that for that sub case of all possible complex relationships, it occurs an awful lot, and it'd be nice to have a common pattern for it.
That's my position also.
I'm a bit worried that once we have this common bucket called complex relationship, we're just going to start throwing crap in there. For instance, if you start concentrating on employment and say, oh, it's a complex relation and it has subjects and objects, you're going to lose the fact that it's actually an agreement. And you should spend a lot more time thinking about it as an agreement. Who are the parties to the agreement, and stay away from, to me, complex relation is kind of a last resort.
Yeah, that's a really good point.
And I do agree with that, Dave. I don't think we should take a, and I've seen this with another client too, where once you do a general class, then you try and take all the stuff that we have kind of with more specificity and then stick it under there. And I'm not a proponent of that. And maybe it stays what it is. The point is, this is a design pattern. Some people have said this feels like more of a pattern than a class. So it hasn't been in just proper, but we've used it as a pattern with lots of clients. So I guess maybe one of the questions is that because that is kind of where this is landing? It's not really a class. We want to make a super class of everything, but it definitely is in my experience, it's a useful, reusable pattern. And it's nice to not have people reinventing this pattern, making it kind of a non-pattern willy-nilly all over the place. It's nice to have some structure around it, as I think Boris was stating.
Can I just pick up on the predicates issue in response to what Mark said, in response to what I said? So you maybe the name, let's say we name this complex relationship employs relationship. So then it becomes clear the direction, right? So then it becomes clear that it should reify in the employs, not is employed by. But suppose we also have a property is employed by, which is now reified by is employed by relationship. But those are actually the same relationship.
Yeah, you don't have to do it that way, though, right?
Right, but sort of from a semantic point of view, the arbitrariness of it bothers me. The arbitrariness that you're reifying it in one direction. Yeah, okay, that's it.
Mm-hmm. So, Rebecca, and I keep hearing you argue this, but you haven't come up with a better solution either.
Oh, I just don't like any of it. I wouldn't do it. That's
well.
I mean,
that's the problem. OWL is directional. Unless you're going to switch to a different modeling language, it was kind of built in.
No, the complex relationship, I mean, the temporal relationship by nature is not directional. I mean, we have two things. They're related in this relationship. They each have a different function in that relationship, but there isn't any particular directionality implied.
Well, there's a time directionality, isn't there? Can we move on, because we've still only got about 5 minutes left. Michael is next, then Ted, then Dan.
There's something nefarious, well, not nefarious, but a little bit subtle happened. So it might have been me who originally came up with this idea to generalize temporal relation. And I thought of complex relation, and it was always a problem thinking of the names of the object or the relationships coming out of the object. Dan had this idea, which we all thought was very good at the time. It solved the problem. Let's have a generic thing called Haswell subject, Haswell object. And so then the idea was make temporal relation a subclass of that. Now suddenly temporal relation only works for binary properties. It was never designed that way per se. So for example, an interesting example of an n-ary relation, a true n-ary relation, where there isn't an underlying binary relation, happened at Procter & Gamble. A particular material is used as a surfactant in a particular product. Okay, that's a ternary relation, it's not binary. But let's suppose that that particular chemical was used as a surfactant for Head & Shoulders, but only for 5 years. And then they realized it was too toxic. So later on, that's a different material is used as a surfactant in Head & Shoulders shampoo. So that would be a different binary relationship. So what's happened is suddenly, we never thought about using temporal relation for ternary relationships, but there's no reason why not. So I just thought I'd mention that.
Mm-hmm. Okay, good. And why would you not just use RDF subject and RDF object?
I still don't have a good, clear articulation of what the difference between RDF reification and this is. They seem closely related, but I don't think they're the same. But I've never been able to fully articulate it. Dave was starting to go there earlier.
Yeah.
We've had conversations on this, but I've never seen a really compelling description that says, "Oh, now I completely get it, and here I can repeat it back to you." I haven't seen that yet.
All right.
Well, you have a statement. You have a statement, and then you have predicates. Like,
Yeah.
the statement has X as a subject, Y as a predicate, Z
Yeah.
as an object, so that you can pull those out, so that you're saying something about those as well as about the statement.
Phil said something earlier, which I thought was correct. He said, essentially, it's the same thing to say something about a triple is pretty much the same thing as putting something on a link. It's kind of the same thing. It feels like, oh, yeah, that's almost identical, but there might be some subtle nuance.
I think it's right. I think that's right. Yeah.
Sorry, we've got Ted and we've got Dan. Let's try and fit them in 3 minutes.
Okay, I'll be very brief. I echo Dave's discomfort. And since I feel I've successfully solved the complex relationship problem in application-specific ways a number of times, I don't feel the need for generality, and I agree that specificity is really what's needed. So that's why I see this more of a pattern than a class.
Have you created your own classes, or have you used blank notes?
I've created classes, and I've created specific properties to express the relationships involved.
And have you subclassed them off anything in particular?
I created my own superclass metric value, which Michael knows about. Yes, and then subclassed that heavily.
Which was specific to that application.
Yeah, exactly.
Dan?
Two things. I'm pretty much find myself in agreement with Dave about this being a pattern as opposed to a class we want to persist. Even though I'm the guy who came up with the complex relation class to begin with, and the 2 properties, or 4 properties. And then, but then that raises the question of, does temporal relation actually belong as a separate class, as opposed to a pattern? It's a topic for another day. But the times that I have really used complex relation, I don't mint instances of a thing called complex relation. Instead, I have to create a noun version of whatever that relationship is, be it ownership, allocation, responsibility, those sorts of things, that give the meaning, the semantic meaning behind what's being reified. So you don't have to rely on an annotation to say, reifies property or some such.
But then you have orphans. You have orphans, Dan. What do you do about the orphan problem? What do you do about the orphan problem? In the case of employment, Dave is correct. You can say, oh, it's really an agreement.
It's an agreement.
These things aren't, oftentimes they're not, like how to place something on a layout. It's not an agreement. That's what you'd call it.
In order to have just something to kind of gather them together, thinking about the clothes hanger, would it be helpful then to be able to categorize a class by a collection of design pattern categories?
Or maybe it makes more sense to do what what Ted did and create a parent class that's appropriate to your domain.
Yeah, absolutely. But I mean, the thing about it is that what we would then do is just to sort of highlight in the design that this is following a particular pattern.
You know,
Potentially.
as a note, as an annotation, sure.
Yeah.
Sure. Yes. Yeah. Okay. All right. Well, look, I think we've come to the top of the hour. There's been a huge amount of extremely good discussion. The chat is absolutely brimful, and we've got a recording there. Where we're going to have to go from this now is back into the discussion about this issue, because there are compelling arguments about binning it and other ones about revising it. So there has to be a certain amount of judgments of Solomon coming in here. And I would like to thank you very much for your participation today, and hope that you enjoy the rest of your day.
Thank
Thank you, Peter.
Thank you. I think you met your objective for the day.
Thank you.
Lots of input. Thanks.
That's
Peter.
great. Thank you all.
Take care.
Thanks. Bye-bye.